Okay, so now I'm going to introduce Susannah. Normally I don't read from notes, but Susannah's career is so interesting and has so much going on, I don't want to forget anything. Susannah Drake is the principal of dlandstudio, which is an award-winning multidisciplinary design firm that includes landscape architects, urban designers, sculptors, scientists, and architects. A truly interdisciplinary operation. dlandstudio is a recipient of national and international urban design awards from the AIA, the ASLA, the Chicago Athenaeum, among others. Susannah's going to talk about some of her recent projects, but I'll just mention a few. A new urban ground, which was designed in collaboration with Architectural Research Office for the Museum of Modern Art's Rising Currents exhibition. The Gowanus Canal Sponge Park, which is a public open space system designed to absorb and remediate urban stormwater. We're really hoping that by seeing some of these examples of really cutting-edge design practice that we'll be inspired here in our region to kind of raise the bar for landscape design and green infrastructure. Susannah has a bachelor's degree, a Bachelor of Arts degree from Dartmouth College, and a Master of Architecture and a Master of Landscape Architecture degree from Harvard Graduate School of Design. She's received grants from the Graham Foundation, the James Marston Fitch Foundation, and the New York State Council on the Arts for research on campus landscapes and large-scale urban infrastructure projects. In addition, though, to her professional practice, she's an adjunct professor of design at both the Harvard School of Design and the Cooper Union in New York. So with that, I'd like you to join me in welcoming Susannah Drake.
Kyle, you're really hard act to follow. I loved your presentation, being a sort of fellow sewer geek. This is a sort of expanded presentation encompassing some work on that involves combined sewer overflows, but also just thinking generally about how to make our cities more resilient. That's my title, Resilient Urbanism, Seeking New Paradigms of Practice, Ecology, Public Space, and Infrastructure. When I started my practice, I thought that I really wanted to think about how to develop new modes of infrastructure, but I didn't really have a defined vision, and what has come out of it is really an idea about making projects happen. And you'll see that in the slides that I'm going to show, but really, I don't really wait to be sort of presented with a project. I go in and sort of find problems and then figure out how to do them, pay for them, make the right allegiances with different entities to actually get them done. So hopefully that will sort of spark sort of new ways of thinking about how we work in our urban environments. So when we look at cities, we often think about sort of the built environment in relation to this lower right-hand slide. That there are these seas of concrete, but considering the work of Eric Sanderson on the Manhattan Project, we also need to be thinking about how there are these natural systems that can actually work in tangent with, or in a sort of more dualistic relationship with this with these urban structures, and that we really can't deny their existence. These cities, a lot of our cities were set up as places of exchange, and they were located in relation to natural water bodies because it facilitated this exchange. And in this case, here we show that exchange happening in a very sort of micro level with people actually taking goods in small quantities off of boats. But we can also think of exchange in a different way, more ecologically. These edges used to be these sort of broader shorelines that had tremendous biodiversity, and they provided a very important function of sort of buffering the upland zones from the extremes of high tides or storm surges. So, but this is really the reality of our urban condition. We have this urban industrial waterfront, and many of these are now post-industrial urban waterfronts, where a lot of this space is becoming vacant. And in part that's happening because of the advent of container shipping. No longer do you have people taking individual sort of crates of goods off of boats, but instead you have these large containers which have different requirements. They need sort of large areas of storage, and you need the big cranes that are going to take these elements off of the boats. And And so what that means is that a lot of this waterfront space is actually opened up for new uses, with the industrial waterfront and transportation systems shifting. But then we also have these new movement systems. This is the Moses' Cross Bronx Expressway. This is a singular infrastructure system. It's really intended for the primary focus of moving cars. But we can think more dualistically. We need to really be thinking about how cities can offer sort of greater level of ecological productivity. And I know the most recent issue of landscape architecture was a little critical about everybody, the landscape architect, so I was referring to Frederick Law Olmsted, but I'm sorry, he's good. And this park is amazing. This is Riverside Park in New York City, and exists over this huge sea of railroad tracks that are an important industrial conduit for the city. We need to kind of go back to that level of thinking. His work is generally cast in a sort of in relationship to the picturesque, but if we think about its sort of productive capacity, I think we can get beyond that and create new modern structures that are sort of more or just have greater efficiency for our cities. So we can't forget that we have this whole system of natural water bodies that exist in many cases sort of below the urban infrastructure. This is the Collect Pond in Lower Manhattan. It's currently underneath the parking lot, and the Parks Department is actually in the process of turning it into a new park. A lot of these areas, if we don't actually think about how we're managing the water, we can be hit with large impacts. This is the water level from the 1938 hurricane that hit the whole East Coast. And you can see on the upper right, that's the Collect Pond in blue. But there is this whole kind of water system that existed historically that has been sublimated to all of this parking. If we don't sort of think about how this water can come in and come out, we're going to end up with a fairly disastrous situation. And this was the 1938 hurricane. Even without global warming or climate change projections, it's been almost 100 years, and this is a 100-year storm. So this is an image that my office created as part of a task force for the City of New York in looking at how to make our waterfronts more resilient. And I'm very happy to say that the City of New York has been doing a lot in relation to trying to think about how to add these ecological layers, but also to think about how we can maintain our industrial waterfront in certain areas, establish special maritime industrial districts, for instance, and maintain our tugboat traffic, and maintain or enhance ferry traffic. So, we don't want to say, oh, it has to be this uniform green edge because, everything should be green. We want to say, okay, we're in a city and there has to be a coexistence of all these different systems. So I'm going to talk specifically about a few sites in New York City, as well as one project that we did as a competition up in Montreal. So I'm going to start with the Rising Currents exhibition. In 2010, I worked with Architectural Research Office in a pretty remarkable collaboration on this exhibition that looked at sea level rise in New York Harbor. This is the exhibition. Ours is the one in the middle, looking at Lower Manhattan. And the collaboration with ARO sort of came out of some research that they had done through a Latrobe Fellowship from the AIA, where they were working with Guy Nordenson to look at these storm impacts and climate change impacts on the harbor. And scientists project that there'll be a 6-foot sea level rise over the next 100 years. The research went to a certain point, and it was really a very smart document, but it hadn't looked more specifically about how these impacts would sort of really affect sort of more localized conditions. So MoMA, in its wisdom, brought in, working with Barry Bergdahl, brought in 5 design teams to actually look at specific sites. Our team, Team 0, was looking at Lower Manhattan. SCAPE was looking at the Gowanus area. Mimi Huang and Eric Bunjay from N Architects were looking at the Verrazano Narrows. Matthew Baird was looking at Staten Island, and LTL looking at Liberty Island area. So we had these 5 teams that were working on site out at PS1. We had studios set up, and it was a really kind of intense environment because we were all critiquing each other. But then we also had representatives from different public agencies that were coming in, and critics from the different architecture schools. It was a really terrific experience, but extremely intense. So here's our site, and I think it's interesting to think about sort of the historic tidelands of 1776, and then relate these to potential inundation levels. And you can see a correlation between the floodplains and these systems that existed in the past. So the edge morphology of Lower Manhattan has shifted dramatically over the last few hundred years, and this was the natural edge from 1650, a much more sort of graded edge, a softer edge, which was great for the ecology, but not so great for shipping. You can see that the large ship has to stay pretty far back from the shoreline. So in order to facilitate the shipping and exchange, by 1850 you had this new hardened edge with these new bulkheads, and then these slips that were actually cut into the edge of the waterfront. Now, Exchange Place actually exists right here. That's where the stock exchange is. And so, you know, the names of the streets were actually, and the places were actually related to that commercial activity. And then by 1960, you had another morphology, these kind of finger piers sticking out into the water, so you could get larger boats into the harbor. But by 2010, we have a different morphology. There's less shipping in the city because of the movement of containerized shipping out. And so we have this recreational edge. And the recreational edge is no longer directly sort of connected to the street structure. So while it's wonderful to have all the parks developing along this perimeter, it's also a bit kind of disconnected from the city. So we really want to think about the 2010 edge morphology, and also really consider the value at risk. Our site had some of the most valuable real estate, sort of probably in the world. And so, the location of the stock exchange is down in here, and Goldman Sachs is over here, and we've got all these huge banks. And if you had one of these impacts, you'd have a huge sort of economic crisis. So we needed to really show that and point that out, and have city officials pay attention, and also have a lot of these companies pay attention. So that was a really great value of the exhibition. And when you actually see it, when you see it in relation to this floor plan, or this site plan, it starts to become a lot more real. But we were also thinking about the fact that New York City also has a combined sewer system. So when we get even a 20th of an inch of rain, our sanitary sewers and our storm sewers combine, and you get these overflows into the harbor. So we wanted to be dealing with the current problem of this fresh water, and then also the potential inundation of salt water. Now, it's a very complex site in terms of jurisdictions. We have state, city, federal officials or entities that all have various jurisdictional levels of control over the area. This is our existing seawall from 2010, but this is what can happen by 2100. You lose all of Battery Park City, for instance. In a Category 2 storm inundation level, you'd actually have 68% of Lower Manhattan covered with water, at least on a temporary basis. So, and then we have this existing combined sewer overflow problem. You can see these are the location of all those outflows. Ours are actually a little bit more sneaky because they're not quite as apparent as the ones Kyle showed, because they happen right at the bulkhead. So sometimes they're actually just even out, right, like almost at the water line. So you can also think about how you may have issues with, if the water level rises and your CSO is below it, then what do you do? So we wanted to think about this water in, water out system, and really create this new urban ground. So this was sort of our area of operation. The area in the lighter grays was where we were working. So we started by thinking about this whole sort of upland system of streets. We have Level 1 streets, which are about absorption. These will work all the time. It's a new street system that helps to soak up all the surface water runoff. And we have level 2 streets, which distribute and collect this fresh water. And then level 3 streets, which are really about protection. So when a storm surge comes in, they get the water out really quickly. And that creates a whole sort of porous green street system. And here you can see the thought on how that might work. I put all of the infrastructure that's currently in the street in waterproof vaults under the sidewalk. The idea is that there would be hatches that you could use for access. So if you ever had a fiber optic line that became obsolete, or a gas line that was broken, or any kind of pipe going through the system that wasn't working, you could get into it easily. You wouldn't have to rip up the street or rip up the sidewalk. There'd be these access points. So, and here's the idea of how that would operate. We also had these porous streets. Basically, we're taking over the whole street bed and making it absorptive. And we also eliminated a lot of the parking that's currently available along the streets, putting it into buildings, or just saying, you know what, Lower Manhattan is really, really well served by public transportation, use it. So here is a system of one of the protection streets with this conduit that would take the water out quickly. And then also an idea about sort of new transportation systems that might happen along the perimeter. So we also were looking at the edge. So we created this new 6-foot hardened edge, new waterfront park space, freshwater wetlands, and then salt marshes at the perimeter. So it's really a combined system that would provide for sort of many different kinds of landscape needs. And here you can see the whole system together and our vision for sort of a new way of thinking about the urban environment that is much more sort of layered and varied. So I'm going to describe them in a little bit more detail. We have this urban estuary at North Street, and here you can see we had the upland spaces and then a transition from freshwater to saltwater marshes. We have walkways that would go out over these marshes and the section of that. And then moving down into other parts of Battery Park City, I actually want to point out that we did actually have to sort of cut into the island to provide these new wetland spaces. And we're not just sort of giving away land to the ecology. We're imagining this as a new kind of urban waterfront edge typology, where this could continue all the way up the edge of the Hudson River in Manhattan. And there'd be development space created and ecological space created. So you'd have this sort of new, it's not just a purely sort of an ecological approach. So here we have the urban estuary at Liberty Street with new marina space, again walkways that go out over the wetlands. And in this case, we've actually taken the waterway through the city. And you can see also suggestion of new green roofs. Here we have what we call the battery breakwater. We put basically a soil into, and silt actually, dredge material into these geotextile sacks, and we'd sink them in the shallows at the battery and have that provide a breakwater for large wave action. If you have a sort of period of a wave, if you can actually break that before it gets to the shore, you'll help to protect the upland resources. So, and then along the East River, we have what we call the East River esker and breakwater. An esker, as all you landscape architects know, is a sort of snake-like formation, mound formation that was formed when the glaciers retreated. And we're going to use that idea as a kind of large berm that can help to protect the East River waterfront. And then outbound of that, we have this estuary space, more of this wetland edge. And then within the old historic slip structures, we have these landscapes that actually can withstand periodic inundation from salt water. So here I'm showing sassafras and other species that can handle the salt or the brackish water. So, and then this is our vision for sort of a new urban experience for New York City, a space that's both resilient and sort of economically productive. And now I want to talk about a project we called Vision BQ Green. When I started my practice, I applied for a grant from the New York State Council on the Arts and developed some of the material that you'll see in this project. We looked at reconnection strategies for downtown Brooklyn. The initial research focused on this area in Carroll Gardens. We were then subsequently hired by a not-for-profit to look at this area in Williamsburg, and so I'm going to show you a couple of those projects. So again, we have the landscape by Moses. He did actually build this incredible series of parkways and parks throughout the city, but the reality was not always so green. Robert Moses, spent a lot of time looking down at it, watching the cranes and derricks and earth-moving machines that looked like toys far below him, moving about in the giant trench being cut through mile after mile of densely packed houses, a big black figure against the sunset in the late afternoon, like a giant, gazing down on the giant road he was molding. This is from the power broker. So this is what Moses was proposing to the community. You'd have this lovely parkway that was surrounded by parks on either side. But this is the reality of what we got. This is the BQE Trench in Carroll Gardens. And, it's a very different animal. So, and you can see, Moses had this hotel room at the Bossert Hotel, which actually looked down on this site, going through this neighborhood. And I have to say, 40 years later, 50 years later, there's still animosity between the neighborhoods, between Carroll Gardens and Cobble Hill and Brooklyn Heights. And Brooklyn Heights actually fought having the trench go through the neighborhood. And you can see where it curves. So Brooklyn Heights now has the Brooklyn Heights Promenade, this lovely triple cantilever of traffic with a walkway above. That's the best views of New York City anywhere. And Carroll Gardens and Cobble Hill have the trench. So, there are these ongoing issues with that. So here you can see that how he really affected the neighborhood, and there are dramatically different real estate values between the upland area and the waterside area, with the houses on one side being worth millions and millions of dollars, and the houses on the other really not. We also have territorial boundaries that exist in relation to the BQE. In Williamsburg, we're working with, it's a primarily the Hispanic community, and on one side we have the Dominican gangs, and on the other side we have the Puerto Rican gangs, and the territorial boundaries are actually defined by the trench. There are also some social issues that we were looking at and trying to find correlations between poverty, physical activity, and obesity, and asthma. The asthma map is actually pretty interesting. And then also looking at the physical impacts of the site, just its physical realities. And then whether some of these park spaces that were created in these sort of extra zones are actually amenities or really attractive nuisance. Are you bringing kids into an area where they're going to be breathing all these fumes? So we looked at, or we used Plan YC. The Bloomberg administration has a really wonderful document called Plan YC where they're trying to look at how to make the city more sustainable in the future. And one of the sort of guidelines is that everyone should have a space within a 10-minute walk of their house. So this map actually shows the relationship of park space to our site. And you can see that in the Carroll Gardens area, there's a big hole. And in our Williamsburg site, we don't actually have the same kind of relationship, but what we're lacking here is recreational space for kids who are, say, 8 to 18. We need more of that kind of active recreation space. So we have a population in our Williamsburg site of about 160,000 and a population in Carroll Gardens of 100, but our median income is much higher in the Carroll Gardens site. So we tried to think about how we might sort of rethink this area, or rethink this structure more generically. We looked at pedestrian circulation, health and safety, vehicular circulation, recreation, environmental benefit, and development, and looked at how those issues relate to the current condition. And you can see here that right now, the car wins. And so we wanted to rebalance that equation. We looked at the existing conditions, the infrastructural barriers, and really sort of analyzed what the different typologies were, and then how we might make a more productive infrastructure strategy with multiple functions by sort of layering on more elements. We also looked at the economics, and this was a really important diagram, I think, both for our office and also for this project in general, because we discovered by using U.S. Forest Service data, or this huge report, that in 1 year, 350 trees will generate $250,000 worth of oxygen, provide almost $500,000 in pollution control, recycle almost $300,000 worth of water, and contribute almost $4 million in shade value. So your net gain is about $50 million. And so what we did was we actually used this diagram we gave it to our congresswoman, who then said to the local DOT, hey, you know what, we need to do this more research on this project, and you know, I can get you, the congresswoman said, I can get you a grant, but for a couple $100,000 to do more work, but you guys need to provide the local match of $60,000. And basically they saw this, and this gain really is benefiting mostly the city. So they thought, you know what, this actually makes a lot of sense, and they funded the project, or at least more study. They didn't fund the construction of it. It's probably $1 billion project. So this is the site in Cobble Hill, and you can see how even adding green walls starts to fill out some of the circle. Here's the site. Susan, can you plug in the tower program? So here's strategy phase 1, and here this is the phase 2, where we added green walls and street trees and a bike lane, and you can see that the circle is starting to expand. And then here, phase 2, and phase 2, and how that would look. The phasing of this was actually also really important, because there was a lot of fear about sort of capping the whole thing right at once, and sort of dismissal of the idea of capping it because it was this enormous project. But showing that we could actually do this kind of intervention in the short term was a really valuable step. And we actually, this was dismissed early on, or in prior generations, because no one actually went out and sort of measured the streets, but they just relied on the survey. So we went out and we actually took a tape measure and measured the streets and discovered that we actually had a couple more feet. So we squeezed the street trees in. So, and then here in phase 3, this would be a capping strategy, and you can see that it really has a huge benefit in all of the categories. So, and here's the phase 3 before. This is what it looks like now. And then our future vision. So in Williamsburg, so because of the work that we had done on that other project through this grant, Councilwoman Reyna, our city council, hired us to do this project, looking at a few blocks of the BQE in Williamsburg. And here we're looking at an area between Boring Point and Broadway, and we really assessed the structural conditions of the site in these different areas and to determine the feasibility. And it was interesting. We ended up only choosing to deck 3 blocks because in this area between South and Broadway, we couldn't get in an intermediate structure. And the reason that was important is that we had to bring, or if we were to do any of this work, we'd have to bring the highway up to federal standards, and that would mean that we'd need 16 feet of clearance underneath the bridges. So in order to get the 16 feet of clearance, we need to keep this deck pretty thin. And in order to keep that deck pretty thin, you need to have an intermediate structure. And that also affected what we chose to put on the top of the deck, which I'll explain a little bit in a few minutes. So we started by thinking about sort of adding traffic calming to the area, but then proposed that we could add some sort of larger open spaces. We added a baseball field and a soccer field. And the great thing about proposing these recreational structures is that we could use field turf, and that doesn't have a very sort of deep profile. We couldn't really get trees and sort of larger shrubs on the center of the site over the deck. So what we did was we proposed to sort of accentuate the edges, or build a sort of richer ecology along the edges, and have the middle part be more of this active recreation space. So here you can see before this neighborhood limitation becoming a new recreational opportunity, this passive use becoming an active use. And then this minimally used park becoming really a place for the community. And you know, the other really important aspect of this is that, and in terms of sort of how I run my practice, is I really try to figure out how to make these things happen. And I think that's why one of the reasons Raina brought us in. She loved our design vision, but she also knew that we knew how to negotiate the process, the public process, and also a larger sort of funding idea. So with this project, you know, these bridges that go over the trench, and the bridges are about 50 years old. The lifespan of the bridges is about 50 years. So the city is going to have to replace them. It's going to cost about $20 million to replace them. We know that there are sort of larger funding streams from the federal government through some new partnerships between HUD and the DOT. And you know, we've been watching Sean Donovan's sort of initiatives, and he's a friend, and I just thought, you know what, we can actually make this happen in this site and benefit the 160,000 poor Hispanic people who live in this area through this idea of this sort of partnership between the federal government and the city. So that's our idea for how we might make this happen in the long term. And you know, as a landscape architect, I really think long term. You know, we plant a garden, or we design a park, and when we first put it in, you know, it's in this sort of young adolescent stage, and it's not going to really achieve its true sort of beauty or grandeur for 20, 30 years, right? So it's kind of the same thing with a lot of these public projects. You know that you're getting in it for the long haul. You're seeding change that will make the city better for our kids and our